How's it going, everyone? Today we're going to be doing another question from Elements of the Programming Interviews in Python. Today we're going to be constructing a letter from a bunch of strings in a magazine. So picture you want to write a secret letter to someone and you want to cut out letters from a magazine and construct it only from those letters. For example, if you want to write 1, 2, 3, and you're given the numbers, the letters 1, 1, 2, 3, then we can simply take the 1, the 2, and the 3, and then we construct the letter from this. But if we have something like 1, 2, 3, we want to write 1, 2, 3, but we are only given the letters 4, 5, 6, then we're not able to do that. So this is quite an interesting problem because once you get the trick, there's a lot of different ways you can implement this, and some of them are more elegant than others, and we're going to explore a few of them. So the trick to this is we want to use a data structure that will allow us to check if a given letter in the letter is present in the magazine. And then we also want to check how many times it appears. Because for example, if we had 111 here, then, well, we wouldn't have enough ones. And if we had 2 more ones here, then we would still be able to do it. So the count matters here and the lookup matters. For us, the data structure that we want to use is a hash table. More specifically, we want to use a counter because we want to have the value in our hash table to store the count of the number of letters. So for instance, for this letter, we need 1, 1, we need 2, 1, 2, and we need 1, 3. In that magazine, it contains 2 1s, 1, 2, and 1, 3. So if you want to think of it as a set, this magazine, it needs to cover all the letters in the letter. And if we're missing any letter, if we had like a 4 here, well then this magazine no longer covers the set of letters. So if you were to draw like a little sort of Venn diagram, then all of the letters in the letter need to be present in the magazine. And using this little bit of knowledge, we're going to take advantage of hash tables O of 1 lookup to be able to do this very, very quickly. So the desired runtime we're going to have here is O of n plus m, where n and m are the lengths of each text. Now, Python has a built-in counter object. If you're in another language like Java or C++, you would have to do this by hand, and it's a little bit annoying, but it's very, very easily doable. You can find different implementations for it. So we're going to say from collections import counter, and let's see. We need to count the letters in our magazine text. So let's say magazine counter equals counter of magazine text. Then we want to iterate over all the letters and the counts in the letter text, and we want to check to make sure that they're covered. So we can create a letter counter. We can say letter counter equals counter letter text. And then what can we do? Well, we can say for char count in letter counter.items. So we're iterating over all the keys and values in our letter, and we're basically going to check if, first of all, that letter needs to be in our magazine counter, but then it also needs to have a lower count. So we're going to say if char is not in magazine counter. So if it isn't in the magazine counter, we're done. We know we can't possibly make this letter because one of the characters is missing. Or another case that we fail is if we do have it in our counter. So we'll say magazine counter of char. What does it need to be? It needs to be less than the count, right? Because if it's less than the count, then we return false. That means we don't have enough letters. So we check is the letter in the magazine? And then if it is in the magazine, we say, do we have enough letters? And then if we don't, we return false. Otherwise, we continue to the next character. And once we've looked through every single character in our letter counter and we know that they're covered, we can simply return true. And then we can test our solution, and we pass this in very quick time, simply because the only time complexity we're losing here is one pass to create the counter, another pass to create the second counter, and then we're doing one more iteration over one of these counters. And then both of these lookups are O of 1. So it's O of 1 to check if the character is in the counter, and it's O of 1 to check the actual value and compare it to the value that we want it to be. So overall, this is going to be O of n plus m, where n is count is length of magazine, and m is length of letter. So this is quite a concise solution. I mean, we have this in 6 letters, but given that we're in a language like Python, I mean, this is kind of more for entertainment value. I mean, how well do you know the built-in functions? I mean, is there any way that we can just check, well, does one set counter the other set? Well, there is. And if you want to be really fancy, I mean, I would not go with this. If you were in an interview, you would definitely not go with this solution right away. You would want to really make sure that the interviewer knows what you're doing, knows all the logic, knows that you understand what the question is asking for. And then you could do something a little bit fancy. Well, what do we really care about? We want to return. We want to check the intersection, or not the we want to check that the intersection between the magazine counter and the letter counter is still the letter counter. So how does an intersection work? This is a bit of a set review. So if you're familiar with the more mathy background, an intersection basically checks that all the values that are in both sets. So if you want to intersection of A, of set A and set B is all values such that, let's say all values X such that X is in A and X is in B. And when you think about it, that's exactly what we want. We want every single value that is both in the letter and in the magazine. And what do we care about? Well, we care that the intersection of this is just the original counter, because that would mean that every value that was in the letter is also in the magazine. So what would we do there? We would say counter of letter text and counter of magazine text. And this is a shorthand for intersection in Python. If you didn't know that, this is just a bit of trivia to know. And we just say equals counter of letter text. And I mean, we could comment this part out, although we would never actually reach it, but let's do that anyways. And if we were to test this, what would we get? Oh, when we still pass our test cases, slightly slower just because, well, there's a little bit of overhead here, but it's okay. Another way you could do this is you can take the difference. So we can say if the difference between the letter text and the magazine text is nothing, that means subtracting every character from magazine text from letter text, whether it exists there or not. If that's an empty set, then that means every character in letter text is also in the character in the counter of magazine text. Now, these are lines that, you know, if you don't get them right away, That's okay. They might take a little while to digest, and it's not really important to know them, off by heart or to know every little detail. But it is an interesting little thing if you want to sort of really wow your interviewer, or if you're just interested in how these set operations work, because they could be applicable for other questions. So we can say we want the difference. We want to say the counter of letter text. We want to subtract every element from the magazine text that is in the magazine text from the counter in the letter text. So we're going to say minus counter magazine text. And what do we want? We want this to be a null set. So if it's null, or if it's none in Python, then we want to return true. So what we want to do is we want to say not. So if this is not, then we return true. And if we test this out, we do the same pass, and since we're not creating an extra counter, it is slightly faster, and that is that. So there's many ways to do this question. I'm sure if you really wanted to play with the sets, you could probably find another way to take advantage of a counter. But really, I would stick with this solution. This is the most concise. You could also one by one remove values from the counter. There's really a lot of flexibility here once you get past the conceptual hurdle of what a counter is and how are we exactly taking advantage of the fact that hash tables have an O of 1 lookup. And using that information, we get a very, very efficient solution, and quite elegant as well. So if you enjoyed this video, please like, comment, and subscribe. And if you're interested in personalized interview help, for example, mock interviews or mentorship sessions or resume reviews, then head on over to our website or fill out the Google Docs and we will contact you. Hope you enjoyed this video and have a great day.